I also have the great good fortune and pleasure of being able to award to Dr. Bredesen a very important award here at the college that we have given out for decades. It is the Grace Goldsmith Award, and we present this award to Dr. Bredesen in recognition of his outstanding contributions to nutrition science in the treatment of neurodegenerative diseases. Please come up, Dr. Bredesen. Thank you.
Thank you very much. I did not know that was going to happen, and a couple of minutes ago he told me that it's for a young person, and I said, well, it's really great to hear that I'm young, but I also understand that that means inexperienced. And definitely this is a new area for me, and it's a very exciting area, so it's a real honor to be here among people whose work I've been reading, like Dr. Brewer's, who published such exciting work over the years, and of course Martha Herbert and David Perlmutter and Dr. Treisman and so many luminaries who've been here. So fantastic meeting. One of the things that really excites me about this is that up until recently, it seems that we all had our own meetings. The molecular neurobiologists would go to this meeting, and the clinical neurologists would go to that meeting, and the dietitians would go to this meeting, and so they'd have all these different meetings. But what's happening is they're all starting to come together. And what I'll show you today is the basic molecular neuroscience that we've been doing in the lab for the last 25 years have led us right into the heart of integrative medicine. And you basically looking at what's happening in a dish can't deny that integrative medicine and functional medicine are the way to go with therapeutics. So we've been very excited to see that play out. I must say I didn't think I would ever see another patient during my lifetime. I thought I would be working on transgenic mice and fruit flies and cell culture models of neurodegeneration for the rest of my life. But when we started to see that, wait a minute, there's something that's telling us how to actually treat humans here that is a little different, and then start to hear the stories from these people telling me about going back to the families, going back to work. One guy said, I have allowed myself to think about the future again. And you can't, that just gets you when you hear that sort of thing. So anyway, thank you so much for the kind award, and thank you very much for the invitation to Corinne and to Meredith and to everyone, Dana and everyone who set this up. So I want to spend the next few minutes then talking about the work that we've been doing related to neurodegeneration and understanding the fundamental nature of it, which is what we've always been interested in, to the point that we can hopefully do something about it. And I want to first just mention a couple of summary points, and then I'll show you those over the next few minutes. So the first thing that we find immediately, and just as people have talked about all the different metabolic profiling to do as well as genetic profiling, if you think about it, as physicians, we've had a big problem. We're dealing with an incredibly complicated organism, and we're getting tiny, tiny amounts of data. So we're asking, what's your sodium? What's your potassium? And then we want to know what's the problem that is happening to this person. So we've had to be, in history, intuitive, which means good guessers. Well, the reality is for 21st century medicine, we want a functional medicine approach, as Jeffrey and Deanna and so many others have pioneered. We want to ask, what is the entire data set that tells us what's going on? Then it's not guesswork. Then we can say, okay, here is the problem, and we can do something about it. So the first thing I want to say is when we just even begin to do that and look at a larger data set than is typically used in Alzheimer's centers, we immediately see that what is referred to as Alzheimer's disease, which is a neurodegenerative process that features phospho-tau and features amyloid beta, if you look at those people, they fall immediately into three different groups, and we've just published this recently. But these are, interestingly, three different and emphasize reversible metabolic syndromes. The second thing is, if you look at what these are, so the first one is hot, inflammatory, and this is a systemic inflammatory problem that affects the brain. And of course, as you probably know, just activation of NF-kappa B, for example, Some of the genes that are activated with respect to NF-kappa B include the beta secretase and the gamma secretase that are important for making the A beta that we see in Alzheimer's disease. So no big surprise, when you have chronic ongoing inflammation, you get this phenomenon. Second thing is cold, and it's a completely different look. These are people who tend to be a little older, and the activation there is not through an inflammatory process, but the activation there instead is from a trophic withdrawal. And the surprise a few years ago, and this is coming from Calisano's lab in Italy and Catania's lab as well, when you simply withdraw trophic support for neurons, guess what happens? You change the balance of APP signaling to produce A beta. So in fact, here are two separate reasons that organisms make this stuff that we call amyloid. And then third thing, interestingly, is a completely different disease. That's the big surprise. Different presentation, and I'll show you an example. Different people, different presentation, different course, and yet, because it has amyloid, we've called it Alzheimer's. And often, if you go to an Alzheimer's clinic, they'll say, well, it's a little atypical, but it's Alzheimer's disease. The CSF is positive, the amyloid PET scan is positive. And these have turned out very interestingly. These are the ones that present with cortical abnormalities, not amnestic abnormalities, typically. And they have turned out to be toxic, and it's very interesting toxic reason, as I'll show you in a moment. And then interestingly, there's a combination, which I call sweet Alzheimer's disease, which we've been hearing about, basically people who develop insulin resistance due to sugar load for many, many years and high glycemic index foods and processed foods and all the things we've been hearing about. And they have this double whammy where they've produced their own insulin resistance. So now we can actually see that in the signaling molecules, IRS1. The phosphorylation is changing from a tyrosine base to a serine threonine base, and this was reported by my colleague Ed Getzel over at UCSF. And when you see that, you now are requiring more insulin for supporting the life of the neurons. You now drop the insulin, so you've got the problem with too much sugar and the AGEs that we heard about so nicely yesterday, but you've also got the problem of too little trophic signaling. So you've literally got both type 1 and type 2. And nutrition, as you'll see, is really playing the key role for all of these. So two of these things, interestingly, so-called hot and cold, are really not diseases. These are programmatic downsizing of a very extensive neuronal network. So you have approximately 1 quadrillion synapses in your brain. And you have, over the years, kept the most important things, how to drive, how to speak, all that sort of stuff. Now, if someone gave you a choice and said, okay, tomorrow, do you want to lose the ability to drive or speak or something else, or do you want to not remember the Friends rerun that's going to play tonight? Which would you choose? And that's exactly what your brain does. And this is why when people come in with typically type 1 and type 2, these are the ApoE4 associated Alzheimer's, and interestingly, type 3 is inhibited, it appears, by ApoE4. So your brain basically is keeping the best stuff. The chance of learning something tonight that's as important as driving and adding and all the things that you have accumulated over your life is low. And so the canary in the mine for these people is the inability to remember new information. That's the first thing that goes in these people. And it's just like in your company, what would you do if you were on the red side of the ledger? The first thing that you would do is to say, we won't add new personnel. You would get rid of the new temporary cubicles so that you could keep the rest of the structure. And that's just what your brain does. And that's why you end up seeing this dramatic hippocampal atrophy early on. You're getting rid of the ability to form new memories. And that's very plastic and can come back, as I'll show you. So the third one, though, is fundamentally different, and it's much more ApoE3. So when you see someone who's 55 years old, comes in with problems calculating and problems organizing, and they're ApoE3, ApoE4 negative, and family history negative, they're in all likelihood going to have type 3. And I see type 3 as a potential hidden, I call it a hidden epidemic, because we're seeing a lot more of these people now. And we've got people now in New Jersey, Texas, Utah, Arizona, Southern Cal, Northern Cal, New Zealand, Australia, all type 3, and unrecognized. And so I believe it's starting to be suggestive that this is an epidemic hiding under the umbrella of Alzheimer's disease. And then finally, just to point out that 21st century medicine uses large data sets and precision programmatics, not a pill, but a program, which is going to be different for each person, instead of the old-fashioned small data sets and one-size-fits-all. So as you know, it's been said, there's nothing that will prevent, reverse, or slow the progress. And in fact, if you go on the Alzheimer's Association website today, myth number 8 is that you can do something about Alzheimer's. And I have to say I disagree with that, and I'll show you why. And the second thing is, people say everybody knows someone who's a cancer survivor, no one knows an Alzheimer's survivor. And of course, with Sharp again, naturally here, and others, we're seeing this. We're seeing people improve. So this is an exciting time, I think, for all of us. So I want to show you a couple of patients. This is a guy who's relatively early in the course, just so that you can compare them to the people I'll show you later. So this is an MD who was diagnosed.
You were diagnosed in 2005. So
Yes.
it's already almost 3 years ago.
That's right.
Yeah. What made you even go to a doctor? And
I had an anger problem. My typical mild self turned into an ogre. My daughter had come to live with her two kids with us. And it turned out that I just couldn't cope with the kids. I wasn't prepared to raise kids again, so it was natural for me to be angry. But my anger was out of control. I would really have spells of anger. And then the other thing that happened was that I was having spells, very briefly, of driving down a familiar street and suddenly being unable to remember where I was.
So two things you see immediately about this guy. He's an articulate guy still at this point in his disease. And in fact, if you ran into him in the street, you wouldn't think anything. You'd think he's a very normal guy. But he complains about the two things that are very, very common in these people. One is that he was overwhelmed. Things he could do before, suddenly he couldn't do them anymore. And I'll show you a woman. Actually, when the woman came to me, I showed her this video, and she said, "Oh, I know exactly how he feels." And the second thing was that he would get lost. He would be driving, and suddenly he would go from kind of feeling like he knew where he was to just not having any idea. Again, a very common problem related to place cells in the hippocampus, a common problem with this illness. So this guy is farther along, and you can see just by looking at him immediately that you would know that he's, unlike the other guy, he's not all there. And you'll see with his daughter who's
Hey,
talking
Dad,
to him here.
what did you do for a living before you retired? Do you remember?
Yeah. I worked in Idaho. Big in Idaho spuds.
Do you remember working in Hollywood?
Oh, yes.
And did you know that you were like a big shot editor in Hollywood? Do you remember that?
Yeah.
So this is another strategy. As you could see, he just says yes to everything. But if you actually dig into what was it, where was it, et cetera, he doesn't remember those things. So as you know, major problem right now, 30 million people worldwide have dementia. Now, interestingly, they never tell you the important number, which is that in the United States, with 318 million people, of course, there are 5.2 million Americans, that's often quoted, who have Alzheimer's. Well, that's because most people are too young to know that they have it yet. So the real question is, how many out of the 318 million Americans are destined to get it, of the people who are alive right now? And the answer is about 45 million Americans. It's about 15% of the population. And of course, if you look at just ApoE4, which represents typically about 65% of the people who have Alzheimer's disease, there are 75 million Americans who are ApoE4 positive and about 7 million Americans who are homozygous. And of course, 99% of these people don't know it. But for the future, the idea will be find out that you have it, make sure that you never get the disease. That's the way things are headed. So as you know, President Obama signed into law in 2011 the National Alzheimer's Project Act, and unfortunately, there is no cure for the disease. There's no plan, and here's how we're going to go about it. What President Obama has said is that he'd like to see something at least 25% better than we currently have by 2025. But 2025, that's a long way from now for people who have this in their family. And as you know, this is going to bankrupt Medicare if we don't do something about it. So major problems coming up. At the same time, there has been no cure for this illness. And unfortunately, you look at all of the failed drug tests, it's really been a disaster. 243 out of 244 in a recent decade. And the one that succeeded, quote, was memantine, Namenda, which has a very, very minimal effect. And so this has been a major, major problem. And if you look, for example, here, semaglutide, over $500 million spent by Lilly developing this drug. Not only did it not make Alzheimer's better, it actually makes it worse. This one here, Dimebon, they didn't believe it when it failed the first time. They did the test again. It failed the second time. So there's something fundamentally wrong with the way we are attacking this. And Alzheimer's really is right now a sad state of affairs. So as you know, the patients, they know that there's nothing out there, so they often don't go in until very late. And as we were hearing this morning, you need to come in as early as possible. In the long run, the hope would be that just as we get our cholesterol checked and our blood pressure checked, you go in when you're 40 years old and 45 and 50, et cetera, and you get your cognition evaluated in a couple of tests, and you're in great shape. And we then should be able to tell people, you will never get this disease. And if you're in the earliest stages, we will reverse it, and we will make sure that that reversal is sustained. The primary care providers typically don't send people to the neurology clinics. They say, hey, I can write a prescription for Aricept. So it's a real problem. And then, of course, when they finally do send them to the specialist clinic, what does the specialist do? They take away the driver's license. They say, I want to do repeated spinal taps on you every 6 months so that I can get data while I watch you go downhill. And people say, well, why do I want to do this? Why would I do that? So, where is classical medicine headed when we look at what's going on with this illness? It's not a good place, and that's why meetings like this are so critical for changing the way that we're heading so that we can get ourselves, out of this problem instead of into the problem. So the question I want to address today then is, how does one go about developing an effective treatment for an incurable disease? So the idea here is that we wanted to understand Alzheimer's disease at a level that is fundamental enough to guide the design of effective therapy. And in fact, if you look here, so these 5 guys, these are activity traces from 5 transgenic mice that have Alzheimer's, and these are 5 mice that are normal. And you can see immediately the difference in the way that they just run around their cages here. So I want to show you then the result of the work, and then I'll come back and show you why we did what we did for these people. So this is a 67-year-old woman. Actually, she's now 71. I just talked to her on the phone a couple days ago. She's doing absolutely great. She's still working full-time, and saw her now 2.5 years ago initially. Her mother had died with dementia and onset at the age of 62. And had been in the nursing home, and it was a typical, very difficult thing for the family. This woman was almost identical in her presentation to the first man that you saw. She was getting lost on the freeway. She didn't know where to get on, where to get off. She was having trouble. She couldn't remember what she'd read. She would start at the top of the page, go to the bottom, and then she'd have to start at the top of the page again. She was unable to prepare reports. She works for the U.S. government. She couldn't prepare her reports anymore. She was unable to recall even 4-digit numbers. She would have to write them down. And she had a retinal scan that was positive for amyloid, greater than actually a familial Alzheimer's patient. And so we treated her at the time with what we call MEND, Metabolic Enhancement for Neurodegeneration. We published that about a year ago. This comes out of the background, the scientific principles that I'll show you here. And at the time, I hadn't seen a patient for 20 years. So when I got a call about this woman, I said, look, I don't see patients. I'll tell her what we're doing in the lab, and if she wants to take this back to her doctor, she's welcome to do that. But what had happened is we had just proposed in 2011, we proposed the first clinical trial, which was a comprehensive trial for MCI, pre-Alzheimer's condition. And this was going to be done in Australia, and it was going to be done with and without a drug that we identified. But the idea was you'd be able to see the whole program. Did that have an effect? Program with placebo, program with drug, and then, of course, drug alone, placebo alone. So we were very excited about this. And both the public and private IRBs in Australia said, we will not allow you to do that trial because you obviously don't understand how to do trials, because you're asking for more than one variable. We said, well, obviously you don't understand the disease, because the disease is more than one variable. So this is a huge issue going forward, that, as you know, IRBs want you to change one thing. But for complex illnesses, you're likely to have to change many things, beginning with nutrition. And so they allowed us, interestingly, to do the trial on the drug alone. So the drug trial is ongoing. But I don't hold great hopes that the drug is a cure for Alzheimer's disease. It's another drug. We have tested it head-to-head in the mice against Aricept and Namenda, and it beats those very well. But those aren't very good either. So in any case, we went through what I call the 36 holes, all the different things that affect this balance, and she called me a few months later and said, I can't believe it. I'm back to normal, I'm back to work full-time. She's still not working full-time at 71, doing great. So I asked her if it would be okay with her if I took a movie of her, and she said, sure, as long as you don't use my name. So as you'll see, these people are all pixelated in their faces because they're back at work and they don't want to lose their jobs.
Tell me a little bit about how things were a year ago.
Well, a year ago, I was having a lot of difficulty. I was very frustrated because my memory was poor. I had issues of being spatially disoriented, particularly when I was driving. I would get off the freeway at the wrong exit or not know where I was getting back on familiar routes. I would reach in my house for a light switch. I'd reach on the wrong wall, even though I'd always had the light switch has always been on the right side. I'd start reaching to the left. I'd call my animals a different name, my pets, and I was really worried about it. I was very stressed about it. So it was a very stressful time.
And how are things at work?
I have a job that requires a lot of mental analysis, a lot of thinking. I do a lot of research. I have to collect data, design the study, and then do the analysis and write a report, usually under pressure. And I was finding that I just couldn't complete an assignment. I couldn't think about the analysis. It was just a jumble to me, and I would start procrastinating and putting it off, and the longer I put it off, the more stress I felt. So I was worried that I was not going to be able to continue with my career.
And tell me a little bit about how things are now.
Things are much improved now. My memory is much better. In fact, I would even go so far as to say I don't think that I have a problem with memory now, which is a great surprise to me from where I was a year ago. My thinking, cognitive ability, ability to do work, ability to do reports, I am back into the stream of things, being productive and being able to do my analysis and writing, which is fantastic.
And how's the driving?
Driving, no problem. I drive at night, I drive in the daytime, I know where to get off, where to get on. I'm on the highway, so I feel like that's a problem. I'm not reaching for the wrong side of the room for the light switch. I'm not calling my pets the wrong name, which I think they're probably grateful for.
And how overall are you feeling?
I feel great. I feel really, really good. I feel energetic. I feel more peaceful and calm about my life, but at the same time very enthusiastic. I've even started writing my book.
Fantastic.
A couple of chapters.
Okay, thank you very much.
So she's still doing very well. I want to show you another guy also just turned 71. This guy's ApoE4 positive, very typical case. FDG PET scan, typical of Alzheimer's, with temporoparietal reduced glucose utilization. He had neuropsych testing, so he documented his own decline, 2003, 2007, 2013, which is when his wife brought him to me. And progressively, his California verbal learning test from 84th percentile down to 1 percentile. So he really had very, very little memory by the time I saw him. Unable to remember lock combination, faces, schedule, etc. A lot of difficulty at work. And one of the common things is when people lose their ability to form new memories, which is more the type 1 and type 2, then what happens is they get a lot of assistance. People are shuttling them in the right thing because they continue to do what they learned to do initially. That stuff tends to stick with them for a while. One of the interesting things that he had, his whole life, he'd been able to add numbers and columns very quickly, and he lost that during his Alzheimer's, and he got it back on the program and has done very well. And then it took about 6 months for him to get better. But interestingly, his wife called me and said, well, you missed the most important thing. And I said, well, what do you mean? She said, well, he was actually accelerating for the 18 months before he came. And then once he started on this, that just completely stopped, and then he started going back up. So he's done very, very well. Just saw him actually recently as well, and he talks a little bit about his problems.
And went to open the locker at my gym, and I could not remember the combination, which is, as I know myself, that'd be very unusual. And I would meet with my accountant, say, and we would just toss out some numbers, and I would have the number faster than he could get to his computer usually. So things like that started to wane dramatically. And went to open the locker at my gym, and I could not remember the combination. Clearly, I mean, the math has come back. That's a real measurable thing. I mean, I'm fast with math again. People I had met, maybe even taken to lunch, I did not know who they were. I mean, it's like a new encounter. And then afterwards, they'd say, you actually know this person. So that's gone away, which is a relief.
So I want to spend a moment then telling you a little bit of why we're doing the things that we're doing. And as I said, we've been interested in the most fundamental aspects. Why does this disease happen? That's been the big question. Why is it so common? Why do people get what is called Alzheimer's disease? So I wanted to go back to just basic biology. If you look at how an organism is made, how all of us were made, basically have to have four processes, a very fundamental level. Proliferation, right? Differentiation, you got to make gut cells and brain cells and all that. You got to have migration, and you got to have integration. No different than if you're going to make a company, you got to have the right number of people with the right skill sets who go to the right place and do the right thing. Now, interact with the right people. So, if you are a lower species, like a nematode worm, when you finish this developmental process, you're done. You're going to live about 3 weeks, and that's it. But if you're a higher species, like a human, then in fact, after you finish this, you get to use these same processes for repair and regeneration. So you live potentially 100 years instead of 3 weeks. But in so doing, you create a lifelong need in balance for these very programs. And we're all used to hearing about the balance that's related to proliferation because it's what's related, of course, to cancer. So you've got oncogenes and tumor suppressor genes, and of course, you've got a balance of these. These are normal genes that are basically causing your cells to divide and survive versus turn over and commit programmed cell death. And of course, if you go out and smoke too much or eat the wrong processed foods or do things that damage your DNA, you have the possibility of having an imbalance here. And it becomes a disease critically because there is positive feedback. The cells that are abnormal actually outstrip the cells in a Darwinian fashion that are normal. Now, nobody ever talks about what the analogy is here with the migration and integration. But what we found is this is exactly what Alzheimer's disease is about. So there are genetics involved and specific proteins involved in synaptic reorganization, literally forgetting. And you're actively forgetting the 7th song that played on the radio on the way to work yesterday and tons of other things. And you're remembering the most important things. And on the other hand, you've got things that are from the remembering side, synaptic domains, and I'll show you how the biochemistry shows us where this occurs. But what happens is, if you imbalance those, then in fact, this is what ends up with Alzheimer's. It is literally synaptoporosis, very much like osteoporosis, where you have many things that are on the osteoblastic side, many things that are on the osteoclastic side. This is now the synaptoblastic side and the synaptoclastic side. And interestingly, the reason this becomes a disease is because there is biological signal amplification, and that, we believe, is where prions come from. So the idea of prions beget more of themselves. So when you have a system in biology that does not require amplification and has only one goal, serum pH, you want to keep it at 7.4, never 10.4, never 2.4. That features homeostasis, negative feedback. But on the other hand, when you have a system that has multi-goal outcomes, like blood clotting, you want to clot, then you don't want to clot, you want to clot, and it requires amplification, then you have a positive feedback system. You literally have a molecular switch, and that's exactly what's going on here. So we can look at each side of the switch, and we can see why these people are chronically on the wrong side of that switch. So the idea here is, whether you're talking about osteoporosis, whether you're talking about cancer, whether you're talking about Alzheimer's, you're talking about chronic illness as signaling imbalances. And we can look at many, many different causes of those signaling imbalances, and we can measure why you are on the wrong side of that. Whether it's from vitamin D being too low, whether it's from mercury, whether it's from high copper-zinc ratios that Dr. Brewer has taught us about, whether it's from many other things, too much insulin resistance, on and on, they all contribute to this critical balance. We can actually look at the cells, and we can see the biochemistry that is involved with their making and breaking contacts, and you can see actually in Alzheimer's, this arrow is always too long compared to this arrow. So for most of your life, you have this wonderful balance where you're making memories and you're forgetting and you're keeping the most important thing. But for these patients, that has changed. And you can blow that up then and just look at APP, and this is the thing that's been implicated for years in Alzheimer's, and now we believe we understand why. Everybody has focused on this one thing, A-beta. But the reality is, it's a much bigger story. This is about a plasticity balance. And interestingly, the things that push you in this direction are pro-Alzheimer's and anti-trophic, and the things that push you in this direction are trophic and anti-Alzheimer's. And this is coming up again and again and again. And interestingly, this molecule turns out to inhibit this cleavage and this cleavage, so you can immediately see where these preonic loops come from. This is basically a positive signal, a positive response, a positive feedback. This one actually inhibits this cleavage event. So once you start going down this side, you can see you immediately get rid of this side. So it pushes you, just as you would if you cut your finger. If you don't clot relatively quickly and you're a cave person, you're going to die. So you have a system of serine proteases that beget more of their own activity. Literally, that is a preonic type loop. On the other hand, if you start going down this side, this one inhibits the cleavage there, the alpha secretase cleavage, but it activates these other cleavages. So you go down this side chronically, and you end up with Alzheimer's disease. So we want to measure everything that's in that balance, and we want to push you in the right direction on that balance. And this is something we published just recently on the connectome of APP, and this is just part of it. You can see this is just like your best salespeople. It has a tremendous network, interactions with all sorts of things, but ultimately it is about making and forming synapses versus reorganizing. So when we first started, we put down all the molecular mechanisms that you'd want to fix if you had a perfect treatment for Alzheimer's. You'd want to prevent the beta cleavage and the gamma cleavage, and you want to prevent the oligomerization, and you'd want to prevent the phosphorylation of tau, and so forth and so on. And there turned out to be 36 of them. So we said, and there's certainly going to end up being more like 45 or 50. We'll see. But it's probably not going to be 500 or 1,000. There's a limited number of things, be they several dozen, that all impact this. And so what I always tell the patients is, if you have a roof that's got 36 holes in it, and the drug company gives you a plug for one hole, it can be a fantastic plug, but it doesn't do that well for you. And that's exactly what the drug trials are showing. You have to carry them out for a long period to get a very, very tiny effect. But if you start covering all 36 holes, you get a big effect. And that's what we did with that woman that you saw and the man. So what we really need now to have is a new kind of medicine, which is very much a functional medicine sort of model. Because if you look at the classical, traditional Chinese physicians, they were very good at dealing with the whole organism, but they didn't know anything about DNA or RNA or microRNAs or epigenetics and all that stuff. On the other hand, today's physician, very good with understanding molecular biology, but really doesn't understand beyond giving a single drug at one at a time, doesn't get that, wait a minute, we need to bring these two together. So the idea is we need to create a new kind of practitioner. And of course, that's what's happening at places like this and at places like Institute for Functional Medicine and many more places with integrative medicine in mind. So, as you'll see, there are new principles when you start to treat these people. And one of the things is you don't stop treating them. You don't give them a pill and say, go home. So this is a woman, 55-year-old attorney. She had all sorts of problems. She actually approached us at a lecture and said, "Can you help me? I have no memory left. It's been a disaster." She would record her conversations. She'd carry her iPad with her because she could not remember anything. So unable to practice, she was trying to learn Spanish as part of her job. She could not. She would get lost in mid-sentence. Interestingly, her kids started doing this, which meant dad and the 4 kids are on one paragraph and mom's 3 paragraphs behind. Her daughter went away to college and came back and said, when I came back from college, my mother was gone. And so she came in and started, and it took many months of tweaking. And she back at work, doing great, and she talks a little bit about herself here.
I couldn't remember conversations that I'd had with my kids and my husband. I started having to refer to my calendar all the time. I had to rely on it or I'd forget appointments. My son showed me how to unlock my iPhone. And by the next day, I could not remember what he had shown me. So there was one particular moment when I knew my memory was improving, and I was out with my husband, and we were having a conversation, and I remembered names before he did. I actually corrected memory that he had, made minor corrections. I remembered it more vividly than he did, and that had not happened in years. So I think that's when I knew that my memory was really recovering.
Okay, so what contributes to the plasticity balance? So we need larger data sets. We want to know your genotype, and now what we're doing, we're looking, and of course 23andMe is a good beginning, but we really need the whole exome and ultimately the whole genome for these people. We want to know your carbohydrate status. We want to know your fasting insulin. We want to know your hemoglobin A1C. We want to know your fasting blood sugar. And as you know, physicians will pick one thing like TSH and say, okay, that's all I'm going to know about the person's thyroid. But that leaves out a tremendous amount of information. So we want to know your hormonal status. We want to know your estradiol and your progesterone and your pregnenolone, your testosterone, your free T3, on and on and on. We need to know these things because they all contribute to that balance. And the amazing thing is, if you look at the molecular biology, they have direct effects on that balance that I just showed you. So for a simple example, estradiol ends up activating, when it binds to its receptor, one of the genes it activates is the alpha secretase, which comes back and cleaves on the good side of that of the APP. So these things have direct input into this plasticity balance. We want to know your metal homeostasis, and again, thanks to Dr. Brewer for his tremendous work in this area. We want to know what your RBC magnesium, and as you know, most people are too low in this area. We want to know what your copper to zinc ratio is, your ceruloplasmin, and so forth and so on. We want to know what your vitamin D level is. And I have to say, I was on the Institute of Aging Council, the NIA's council a few years ago, when this report on vitamin D came out. And it was embarrassing to be on the council, I have to say. So I asked one of my council members, who's an expert in this area, and this was the middle of winter in Bethesda. And I said, well, what do you think your vitamin D is right now? And she looked at me and she sneered and she said, nice and low, like it should be. And, and her argument is, because we measure these low vitamin Ds, it must supposed to be that way. And I said, yeah, but you're dressed fully, you're in the middle of winter, you're not outside. Maybe that's not supposed to be the way life is supposed to be, So it's interesting to me that people keep coming up with this idea that it's fine to run these very low vitamin Ds, which I think, and we've heard at this conference, obviously, is a horrible idea. So obviously, methylation status, incredibly important. Your barrier status. One of the things we're trying to do right now with the genetics is ask, can we now segregate people into, okay, these are the people that have mostly problem, 1, 2, and 5, or 6, 7, and 8, et cetera. But we're doing the same sort of thing that you see with oncology, where they're comparing the tumor genome to the host genome. We're essentially looking at your metabolome. We don't have a tumor to biopsy in Alzheimer's disease, obviously. So we have to ask, what is causing your brain to get the signals that say, pull back? We want to know your antioxidants, toxin status, and so forth and so on. And we want to know your inflammatory status. So many things to look at with these. And this, I realize this is hard to see. I want to throw it up here just as an example. This is a real patient. This is a guy who came in a year and a couple of months ago, 65-year-old. And as you can see, you can see as the metabolism goes, so goes the cognition. This guy, ApoE4 positive, both parents had died with Alzheimer's. He's a practicing physician, but he didn't bother to check all of these values which were abnormal on him. So I had to fight with this guy. He's a genius. He went to Berkeley when he was 15, so he would argue with me about every single thing I would tell him. I was like, you have to do this. No, I don't want to do that. You have to do this. He says, there's no evidence for this. I said, yeah, but the evidence is typically collected on one variable at a time. The evidence doesn't tell you what if you put these things together. So he finally, it took me a few months to get him going. He's back at work. He's doing great. And I'll show you, so he had a very well documented Alzheimer's, positive amyloid PET scan, positive FDG PET, abnormal neuropsych testing, MRI with hippocampal atrophy. So his hippocampus, this genius, was down to the 17th percentile. After 1 year on this program, I asked him to go back and get it again, and he said, brains don't grow. And I said, look, just please humor me. Go back and get your MRI again. So then he called me up. It turned out he's at the 75th percentile. So as you can imagine, the neuroradiologist did not believe this. He said, we've never seen this in over 75,000 scans. So we sent it to another group to look at this separately, which is called Brain Reader. NeuroReader is their program. And they found that, in fact, we had actually slightly underestimated. He actually did a little better than this. So he's doing very, very well. So I want to just mention a word about type 3 because it's something I truly believe we're going to see a lot more of. So here's a 52-year-old professor, 2 years of cognitive decline, began not with amnesia. And these people typically begin with primary progressive aphasia, as they call it, dyscalculia, very common, problems organizing, changing their personality, they're having trouble, they're falling apart, and yet they're not frontotemporals. These are true Alzheimer's, well documented. But interestingly, they're typically ApoE4 negative, family history negative, almost always preceded by severe stress. This woman had had 4 anesthesias, had a lot of stress in her life, grant writing issues, job issues. Going through menopause also seems to be a common thing that happens with these, or andropause. CSF was positive for Alzheimer's, so she had a high phospho-tau, low A-beta 42. Amyloid PET was positive. Her MRI showed general atrophy, not just hippocampal atrophy. And so the diagnosis of AD was made at a major university medical center, and I got a call from someone there who said, would I also see her? And I said, well, you know, she's just been seen by arguably the most outstanding Alzheimer's center in the world. But as we looked through and we said, you know what, there's something wrong. She has type 3 and there may be some toxin here. So I end up sending her to one of Dr. Shoemaker's certified mold specialists because my concern was that she actually had mycotoxin exposure. She ended up with a C4A 10 times normal, TGF-beta 6660, which is about 2 times normal, MMP9 high, and in her home they found Stachybotrys, Penicillium, Aspergillus. We're seeing this, we have about a dozen of these people now. We're seeing this repeatedly. And Dr. Walls mentioned mold this morning and the fact that it may be under-recognized, and I could not agree more. These people are coming up again and again and again. So the time is short, so I'm going to zip through this last little part here, but I want to mention a little bit about ApoE4. We have a paper coming out of this because ApoE, as you know, is supposed to be a fat bucket, right? It's the thing that carries around lipids. How the heck can it have so much to do with evolution, cardiovascular disease, Alzheimer's disease, inflammation? It doesn't make sense for a fat bucket to do that. So we started a project a few years ago to ask why. God came down and changed the simians into the hominids and allowed us to do things that we couldn't do before. And there's a small set of genes that changed, including ApoE. ApoE4 appeared. It was the first and original, it's the primordial human ApoE. And throughout all of history of humans, it's been only ApoE, of the hominids here. Just 220,000 years ago, ApoE3 appeared, and then just 80,000 years ago, ApoE2 appeared. And these look very different, as you can see. ApoE4 looks like columns. ApoE3 looks like a nutcracker. Very, very different, and it's just because of one change, one mutation here, cysteine 112, which now attracts the arginine 61, so it doesn't interact here with glutamate 255. And here's the surprise. It turns out that ApoE is a transcription factor. It's a transcriptional repressor. So we discovered that it actually binds with high affinity to DNA of all things. So what actually happens, the unexpected mechanism here, and this is the work of Ram Rao in the lab, and Veena Thindakar in the lab, who've published the beginning on this, and we've got another piece coming. So they've mapped 1,700 different promoters that this binds to, and if you look at these things together, you couldn't write a better story for Alzheimer's disease. The genes whose promoters are bound by ApoE4 are things involved with inflammation, microtubule disassembly, glucose homeostasis, synapse dysfunction, aging itself and sirtuins, and neurotrophins and cell death. You couldn't write a better story. So it really gives us a new way now to look at how ApoE4 is giving you that risk for Alzheimer's disease. So, is Alzheimer's disease incurable? One of my favorite quotes is from Margaret Mead. She said, "Never doubt the ability of a small group of committed individuals to change the world. Indeed, it is the only thing that ever has." And this is exactly the sort of group that she was talking about. So thanks once again for the invitation, and we thank the people in the laboratory who've done the work over the years. Thank you.